Welcome to the AI Chat podcast. I'm your host, Jaden Schaefer. Today on the podcast, we have the pleasure of being joined by Praveen Kolli, who is a staff machine learning engineer at DoorDash, specializes in developing deep learning models for improved ad recommendations and enhanced user experience. Formerly, he was a technical lead at Pinterest, contributing to cutting-edge models for personalized ad recommendations. He holds a PhD in mathematics from Carnegie Mellon University, a master's in mathematics of finance from Columbia University, and a bachelor's in electrical engineering from IT Kharagpur. Welcome to the show today. Super excited to have you on.
Thank you for the introduction, Jaden. It's a pleasure to be here with you today.
Like I mentioned, super excited. I saw you at the AI4 conference earlier this summer in Las Vegas. You've been working on some really incredible stuff, so I've been wanting to get you on ever since. What I would love to kind of kick this off with is if you could briefly give us a little bit about your background and your journey. What brought you to doing what you're doing today? Was this something you were always interested in, or was this something that developed? Give us a little bit about your journey.
So I came to the States in 2011 to pursue my master's in financial mathematics. I studied a lot of probability, stochastic processes back then, and then I really liked what I was studying, and then I decided to pursue a PhD in the same area, probability theory. And then when I was pursuing my PhD, I really like the field of statistics and machine learning, and in
Have you ever wanted to start your own podcast? I record and publish podcasts on a platform called Spotify for Podcasters, and I absolutely love it. Essentially, you can upload from your phone or computer, and it distributes to every platform that plays podcasts. They support video podcasts, and you can make money on the platform with ads or even podcast subscriptions, something that has made my life so much easier as a podcaster. So if you're interested, I highly recommend you give it a try. You can download the Spotify for Podcast app, or go to spotify.com/podcasters to get started on your podcast today.
This episode is brought to you by Shopify. That's the sound of switching your business to Shopify, the global commerce platform that supercharges your selling. Harness the best converting checkout and same intuitive features, trusted apps, and powerful analytics used by the world's leading brands. Stop leaving sales on the table. Discover why millions trust Shopify to build, grow, and run their business. Sign up today for your $1 per month trial period at shopify.com/tech23.
some sense, probability is the foundational pillar on which statistics and machine learning rests. So I was excited about all the technological advancements that were happening in the technological world, and I decided to transition into the tech space during my PhD.
Super cool. So, you're working on some really incredible stuff right now. Something I'd love to ask you a little bit about is, how do you approach developing deep learning models for ad recommendations, for example?
So let me take a step back. There are different modules within the ads funnel. There is the ads targeting, there is the ads retrieval, there is the ads ranking, there is the ads auction, there is marketplace auction, so on and so forth. So in the ads targeting, advertisers basically create campaigns and they tell the publisher, it could be Google, Facebook, Pinterest, Snap, any company pretty much, who they want to target. Hey, I want to target users in LA, New York, age between 20 to 35 or 50 to 65, people who speak in a particular language, or people who are logging in from an Apple or an Android device. So you have all these filters based on which you can target users. So so there are machine learning problems in each of these modules. Right, there are some machine learning problems that you're trying to solve in the context of ads targeting. There are some machine learning problems that you're trying to solve in the context of retrieval and ranking. So in the context of targeting, it's common to do what is known as keyword targeting or set-based targeting. For example, if you're an advertiser, you say, hey, these are the users that I have. I'm going to give you their email IDs. Find me similar users. So target these users, also find users similar to these users. So you build a model for doing audience expansion. So this is in the context of targeting. Similarly, you could do keyword expansion. For example, if you're targeting, let's say, a keyword like Pepsi, maybe you would also want to target the keyword Coke. So things like that.
Right.
So there are machine learning problems, as I said, and these are common machine learning problems that are dealt with in the context of targeting. And then in the context of retrieval, now, if you have a big repository, let's say you have 500 million ads in your repository, every time the user comes to your platform, you want to show relevant ads to the user. So what it essentially means is for every user ad pair, you want to predict the likelihood that the user is going to engage with this ad. Now, if you have 500 million ads in your repository, for every user, computing the likelihood of engagement with each of these 500 million ads is not feasible, right? So you have mechanisms to trim down the number of candidates that you want to score, right? So targeting is one of the filters that you apply to trim down the candidates. Say, I'm gonna only look at, as I said, right? Advertisers provide some specs, targeting specs, location, age, gender, language, device, so on and so forth. With that, you can trim down certain number of candidates. And then in the retrieval stage, you do further trimming using lightweight ranking. There are other techniques such as embedding based retrieval that people normally use to trim down candidates. And then you have the trimmed candidates that are sent to the ads ranking layer, wherein you have a fairly heavyweight machine learning model to predict the likelihood that the user is going to engage with this subset of ads. And then you do auction, and then you figure out what the best candidates are, and then you show these ads to the users. Now, to answer your question, how do I go about building a deep learning model? Even before I go about whether to build a deep learning or not, I want to understand the context. I want to understand the system requirements. Say, how many requests am I going to get per second? What are the latency requirements? Do I have the infrastructure to serve a complex model online? Right? You, for example, if you're Facebook, you're getting you have the QPS is very high, right? They have billion daily active users, so the QPS is going to be very high. So you want to have a system that is not going to melt down when the traffic increases. So you look at all the requirements, you look at infra cost, because building a complex model also costs a lot of dollars. You look at all these things, and then finally, assuming you have all the other things have checked out, then you look at the data, and then you look at the amount of data that you have. Does it make sense to build a deep learning model? Like, what is the kind of data that you have? If you have a lot of categorical features, lot of textual data, then deep learning blends really well with such kind of data. So yeah, I think you have to look at all of these things in totality before deciding whether to build a deep learning model or not. So given a particular problem, you just don't jump in and say, hey, I'm going to build a deep learning model.
Okay. Yeah, no, that makes a lot of sense. So fascinating, the different challenges and concepts you have to think about when you're building these things. I'm wondering, what are some of the common frameworks that are used to build machine learning models in kind of the space these days?
So PyTorch and TensorFlow are the most popular frameworks that people are using these days to build deep learning models. Yeah, I think TensorFlow was more popular until some time ago, but I think PyTorch has surpassed TensorFlow in my opinion. A lot of companies are moving towards PyTorch.
Okay. Yeah, that's interesting. I do see that. I do see that a lot. It's going to be interesting to see how the landscape continues to evolve in that regard. In regard to kind of everything you're working on, how do you like essentially ensure data quality when you're building machine learning models for user experience?
This is a complex question. There are a lot of things again one needs to look at when you're building to ensure that the data quality is maintained, right? So one, you have ETL pipelines that are basically generating features for your downstream machine learning or deep learning models. So you have to set up all kinds of alerts. Oh, if the ETL job failed, then you want to set up an alert. Or for a particular feature, if the feature distribution has changed significantly, so you can do that by monitoring the 50th percentile, 90th percentile, 99th percentile, or mean, standard deviation, so on and so forth. You have to monitor the change in distribution. If the distribution has changed significantly over time, you want to set up alerts. You want to set up alerts at the level of, hey, what are the number of null values that you're seeing for this particular feature? So these are some things that you need to do to make sure that you're maintaining data quality. Yeah, I think that's I think the bare minimum thing that one should do to make sure data quality is maintained.
Yeah, no, I think that's fairly important. So something I'd love to ask you about, what are some of the common pitfalls in data strategy that can lead to ineffective machine learning models? Maybe these are mistakes that people are currently making today. They don't know they're doing. Tell us a little bit about some of the common pitfalls.
So logging, how you're logging the data to build your models, I think that is extremely important. Especially, it is important to log features when you're serving to minimize what is known as the training serving discrepancy, right? So, for example, if you log a training instance, training example, and then let's say you do not log all the features, and then you are relying on offline pipelines to do backfilling, so on and so forth, for generating features. Depending on how careful you are, if you're not very careful, it's possible that the model that you're building, there is bias that is introduced because of this, and then it could have potential implications on the performance of the model when you're actually serving it online. That's one thing. In the context of ads, attribution is extremely important. When I say, what I mean by attribution is, let's say you go to Facebook, you look at an ad. Let's say you look at an ad from Macy's. You click on it, but then you don't do anything. But then a week later, you go to Macy's.com and then you make a purchase, right? So so the conversion label that you actually made the purchase, Facebook is going to get it a week later, but then they will append that label to the ad that you saw a week ago. So this is called as attribution. So in the context of conversion ads, using attribution windows of 1, 7, 30 is fairly common. Do you have the right attribution windows set up to build your models? That's one thing that is important. There could be other examples. For example, another concrete example that I can give you is, let's say in the context of Apple iOS 14 changes that were rolled out a few years ago, where Apple essentially said you need to get explicit consent from the user to access the user's offsite activity. Now, let's say you have a model trained prior to iOS 14 rollout. So this has, you're accessing both opt-in as well as opt-out users' offsite activity. Now, let's say post iOS 14 rollout, so let's say a significant chunk of the users have said, hey, don't track my activity on third-party websites, but you are still continuing to use the same model that has offsite features baked into it. Now, when you're serving these model which has offsite features baked into it, but now in the context of all the changes that were introduced, now all these features are going to be null because you can't use them. So you're going to use, say I'm just going to use a null value or as a default value. And then that would lead to a significant drop in performance, right? So these are a few things that can go wrong.
Okay. Yeah, that makes a lot of sense. And it's so interesting because obviously the the technology landscape is changing, and like, you know, the iOS update and others can come down the pipe and really kind of, you know, can change or break stuff. So you really have to be on top of what's happening to understand how everything is impacting you. How do you decide on the right tech stack for data operations in a machine learning project typically?
So that's a good question. It depends on the scale of the company. I think with big tech, big tech has its own tech stack, right? But if you're a small companies also use a lot of enterprise software, or they could just use, let's say, GCP,
Mm-hmm.
Amazon AWS. I think instead of trying to build everything from scratch, you could just use Amazon AWS, and then you could uh, get started fairly quickly. In terms of, if I were to talk about the rough tech stack, right? So there is offline development, offline feature development, offline model development, and then there are near real-time features. So you need to have a separate architecture for serving near real-time features. You need to have a streaming architecture for that, and then you need to have ability to serve.
This episode is brought to you by Klaviyo, the platform that powers smarter digital relationships. With Klaviyo, you can activate all your customer data in real time, connect seamlessly with your customers across all channels, guide your marketing strategy with AI-powered insights, recommendations, and automated assistance. Deliver experiences that feel individually designed at scale and grow your business faster. Power smarter digital relationships with Klaviyo. Learn more at klaviyo.com/Spotify. That's KLAVIYO.com/Spotify.
Machine learning models online, right, to real-time traffic. So for offline ETL development, you have Airflow is fairly common, developed by Airbnb. These days, a lot of companies are also using Databricks for setting up their ETL pipelines. And then, once where do you store the output of the ETL pipelines? A lot of companies store their data in S3 buckets that is provided by Amazon. If you're using the Amazon AWS. So, and then what frameworks are you using to build machine learning models? PyTorch, TensorFlow, and then how exactly are you doing model deployment? You can use open source frameworks such as Spinnaker for doing model deployment. But if you're on, let's say, Amazon AWS or GCP, you come up with services that are developed in-house, either by Amazon or GCP, and then you can get started fairly quickly.
Okay. So in the industry right now, you know, there's a ton of academic research that's coming out from a lot of, you know, the top tech companies on, you know, different technologies that could impact AI and machine learning and kind of what's being built. But of course, there's like the famous Transformers paper that kind of made a massive impact because that's what a lot of our natural language processing is built on and whatnot. I'm wondering if you can discuss some of the challenges of translating academic research into real world applications.
Yeah, so one of the challenges in the context of ads recommendation, or in the context of recommendation systems, is you can build a model offline, which is fairly complex. But if you need to serve it online, there are different set of challenges that you'll have to deal with. Meaning, for every request that comes in, for every user that opens facebook.com or pinterest.com or snap.com, the page needs to get rendered in about 500 milliseconds, right? So the whole page needs to load in about 500 milliseconds. So what that essentially means is there are strict latency requirements. You could have a really good model that has very good offline performance, but when you try to serve it online, because it's so complex, you won't be able to serve it online, meaning you won't be able to meet the strict latency guidelines. So it could probably take you a second to do inference. That potentially leads to a very bad user experience, right? No user wants to wait for a second for the page to load. So that is one challenge that I see. You could have really good models. You could develop really good models that have great offline performance, but sometimes it is very challenging to serve these models online. There are techniques that one can use in such scenarios. You could do what is known as quantization. You could do what is known as knowledge distillation. You could also do GPU serving. With GPU serving, now you could serve really complex models within the same latency requirement, within the same latency budget. So, yeah, I think TLDR is sometimes you can develop really good models, but you may not necessarily be able to serve them online.
Gotcha. Okay. Yeah, that makes a lot of sense. And I'm sure, yeah, it's just one of those challenges that comes. One thing I would love to ask you about is, what skills do you think are essential for someone aspiring to specialize in machine learning for ad recommendations?
So, someone who's aspiring to start in this area, I think, having a solid math background, everyone should have a good background in basic calculus, probability, basic statistics, linear algebra, and then these days there is so much material over the web. There are a lot of good machine learning courses that are offered by a slew of universities, and all of these videos are available on YouTube as well. There are good courses offered by Stanford, good courses offered by CMU, MIT likewise. So having a good background in basic machine learning fundamentals, deep learning fundamentals, I think is a prerequisite. In addition to that, there are also good podcasts, right? In this space, you run one, and then there are also a lot of good blogs, engineering blogs that are maintained by companies themselves. I think it's great if one could read these engineering blogs, Google's or Facebook's or Pinterest, Snap, DoorDash. All of these companies have very good engineering blogs. So one could read these engineering blogs and then stay current on what is going on in the industry.
Yeah, I love that. I think that's so important. And I really do think just that that's great advice, because I think that whole continuing education aspect, or obviously you got to be educated to get into it, but even when you're in it, you got to stay on top of this. You've talked so much about everything changing, and so yeah, these are incredible resources to make sure you're really staying on top of everything. As we wrap up the interview today, this has been absolutely phenomenal. I'm wondering if you could kind of wrap this up, if you could tell us how you measure the success of a machine learning model in a business context. What are those, what are the success metrics that you're kind of measuring these on?
So in the context of ads, there are different metrics that you look at, right? So there are, in the space of ads, there are three players. There is the publisher, which could be Snap or Pinterest or Facebook or Google. There is the consumer or the user, and then there is the advertiser. So you want to make sure the advertiser is happy, you want to make sure that the user is happy, and then you also want to make sure that the platform is generating enough revenue for it to sustain, right? So you can't look at one metric in isolation. It is important to look at all the metrics that are user facing, advertiser facing, and impacting the platform itself. So some metrics that are that are important for the platform is revenue, monthly active users, daily active users, so on and so forth. For advertisers, okay, what is the revenue over ad spend, ROI that we are delivering to the advertisers? That is important. Click-through rates, conversion rates, the cost per acquisition or cost per conversion. These are important metrics. CAC, these are important metrics that advertisers care about. So there is not one metric that you look at in isolation. So you look at all these metrics, user facing, advertiser facing, and impacting the platform itself. in the content. For example, some user-facing metrics could be, hey, how many times has this user saved, session time. For example, if you're showing too many ads or if you're showing bad content to a user, the monthly active users are going to go down, daily active users are going to go down, the session length, session time is going to go down. Different engagement rates with either organic content or ad content is going to go down. Hide rate, hey, how many times is the user clicking on hide or report something? If that is going up, that essentially means that the platform is not doing a good job at recommending good content to the user. So there are a lot of metrics. As I said, you look at all these metrics in totality. You don't look at one metric in isolation.
Okay, yeah, I love that. Praveen, thank you so much for coming on the podcast today, sharing all of your insights. This has been absolutely phenomenal. To the listener, thank you so much for tuning in to the AI Chat podcast. Praveen, if people are interested in getting in contact with you, what's the best way for them to do that?
They could reach out to me on LinkedIn.
Okay.
Yeah.
Wonderful. Again, thanks so much for coming on. To the listener, thanks so much for tuning in. Make sure to rate us wherever you get your podcasts, and I hope you have a wonderful rest of your day.